now we've covered material dealing with molecules and atoms, and the next section that we're going to investigate is what happens when these atoms or molecules come into contact with each other or collide with each other. What type of reactions are we going to observe, and what type of reactions could we predict? So the next section is titled Chemical Equations, and a chemical equation is a symbolic representation of a chemical reaction is called a chemical equation. And in these chemical equations, we typically represent the starting materials over on the left-hand side. We give a little arrow and have the final materials over on the right-hand side. So we're mixing two or more things together, and that's going to give us some type of other products. Okay? So the way chemists refer to our starting materials is we define these as reactants, and the end result are going to be the products. So the left-hand side of a reaction is the reactant side. The right-hand side of a reaction is the product side. So when we write these chemical equations, we can say that if we have sodium solid plus oxygen as a gas, the product that we observe is sodium oxide. And the sodium oxide is a solid. And if we remember from our nomenclature, sodium oxide, sodium is a +1 charge, oxygen has a -2 charge, so this has to be Na2O, and it's an ionic compound. So our product is Na2O. When we react the sodium together, sodium is Na, oxygen is going to be represented as O2 because it's what we refer to as a diatomic gas. So in its standard state, oxygen is going to be represented as O2 because it is a diatomic molecule. We'll get back to that in a second. But once we represent this chemical equation, we need to balance it. We need to make sure that the number of atoms on the left-hand side is equal to the number of atoms on the right-hand side. In order to do this, we need to put a 2 in front of the sodium oxide because there are 2 oxygens over here on our reactant side. That leaves 4 sodiums on the product side. On the reactant side now, we need a 4 in front of the Na. So now this equation right here is balanced. All right? To mention something about balanced chemical equations is that we need to balance chemical reactions because the total number of atoms of each type remains unchanged. And this goes along with the law of conservation of matter. We cannot create or destroy an atom. It can change form, it can change what it's bonded to, but the total number of atoms is going to be the same. Okay? And we can balance these equations by adjusting the coefficients. So we can't change the actual molecule, but we can change how many, or we can represent with a coefficient how many of that particular molecule will be either reacted or produced. One thing I want to come back on before we move to the next section is these diatomic elements. And some elements are more stable to exist as diatomics. Okay? There are 7 of them that you're responsible for knowing: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. If you look on the periodic table, starting with nitrogen, element number 7, going over to fluorine, coming down to iodine, it makes an upside down L on the periodic table, and in addition, you have hydrogen. So these are the 7 diatomic elements that you're going to need to be responsible for. So if I say nitrogen gas, you need to recognize that that nitrogen gas is N2 and not just N. So here are all our diatomics. They're going to come into play when you're writing out these reactants and products that you observe in the chemical reactions. So we're going to look at 3 main types of reactions in this section: combination reactions, decomposition reactions, and combustion reactions. And in the next video that we put together, we'll go over some tips for balancing these chemical reactions.